Download this code from codegive.com, link in the description below. In computer graphics, particularly in the context of 3D rendering and game development, attributes play a crucial role in optimizing geometry to make it smaller and faster to process. This tutorial will cover the concept of attributes in 3D geometry, how they can be optimized, and provide code examples to illustrate the principles. What are attributes? Attributes in 3D geometry refer to additional data associated with vertices, edges, or faces. Common attributes include position, the 3D coordinates of a vertex. Normal, a vector perpendicular to the surface, used for lighting calculations. Texture coordinates, used for mapping textures onto surfaces. Colors, vertex colors or material properties. Why optimize attributes? 1. Performance, reducing the amount of data sent to the GPU can improve rendering performance. 2. Memory usage, smaller attributes consume less memory, which can be critical for large scenes or limited hardware. 3. Network bandwidth, in networked applications, like multiplayer games, smaller data sizes reduce latency and bandwidth usage. Techniques for attribute optimization. 1. Use fewer vertices, combine geometry where possible. For example, use indexed geometry to share vertices between faces. 2. Reduce data precision, use lower precision formats for attributes. For instance, using half instead of float where high precision isn't necessary. 3. Attribute packing, combine multiple attributes into a single attribute to reduce the number of vertex attributes. 4. Level of detail, LOD, use simpler geometry for objects that are far away from the camera. Code example, optimizing attributes in a 3D model. Below is a simplified example of how to optimize vertex attributes in a WebGL context. This example demonstrates how to pack color and texture coordinates into a single attribute. Explanation of the code. 1. Vertex and fragment shaders. The vertex shader processes vertex attributes, position, texture coordinates, colors, and passes them to the fragment shader, which outputs the final color. 2. Buffers. We create separate buffers for positions, texture coordinates, and colors. 3. Attribute linking. We link the buffers to the shader attributes. This allows the GPU to access the vertex data during rendering. 4. Draw call. Finally, we clear the screen and issue a draw call to render the triangle. Conclusion. Optimizing attributes in 3D geometry can significantly enhance performance and reduce memory usage. By using techniques such as reducing precision, packing attributes, and utilizing indexing, developers can create more efficient graphics applications. This tutorial provides a foundational understanding and a practical example for further exploration in 3D graphics programming. Tutorial: Using attributes to optimize geometry in 3D applications. When working with 3D graphics, especially in real-time applications like video games or simulations, managing the size and performance of your geometry is crucial. One effective way to achieve this is by utilizing attributes efficiently. Attributes can control how geometry is processed and rendered, allowing you to reduce the amount of data you need while maintaining visual fidelity. What are attributes? In the context of 3D graphics, attributes are additional data associated with vertices, such as color, texture coordinates, normals, and custom data. By using attributes wisely, you can reduce the complexity of the geometry and improve rendering performance. Benefits of using attributes. 1. Reduced data size. By using fewer vertices or smaller data types for attributes, you can significantly reduce the size of your geometry data. 2. Improved performance. Less data means faster processing on the GPU, which translates to better frame rates and responsiveness. 3. Custom visual effects. Attributes can be used to create advanced visual effects without heavy geometry, such as instancing or dynamic effects. Strategies for making geometry smaller and faster. 1. Optimize vertex attributes. Use lower precision types, example half instead of float. Combine attributes when possible, example pack UV coordinates into a single vector if applicable. 2. Use instancing. Instead of duplicating geometry for multiple objects, use instancing to draw multiple objects with a single draw call. 3. Level of detail, LOD. Use multiple versions of the same object with differing complexity based on distance from the camera. 4. Geometry shader. Use geometry shaders to dynamically create geometry based on attributes rather than predefining it. 5. Efficient indexing. Use indexed drawing to reduce redundancy in vertex data. Code example. Here's a simple example using a hypothetical game engine or graphics API, like OpenGL, to illustrate how attributes can be optimized. We will focus on reducing the size of vertex data by using fewer attributes and instancing. Explanation of the code. Vertex structure. We defined a simple vertex structure with only essential attributes, position and texture coordinates. Creating geometry. The create quad function creates a quad using the minimal number of vertices and attributes. Drawing with instancing. The draw quad function demonstrates how to draw the quad multiple times with instancing, reducing the overhead of multiple draw calls. Conclusion. Using attributes effectively is key to optimizing geometry in 3D applications. By being mindful of how you structure your vertex data, using instancing, and applying other strategies, you can create more efficient and faster rendering scenes. Remember to profile and test performance, as optimizations can vary based on the specific context and hardware.